With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, in this question it is given that a small electrically charged bead can slide on a circular frictionless insulating rod. A point-like dipole of dipole moment P is fixed at the center of the circle with the dipole's axis lying in the plane of the circle. Initially the bead is on the plane of symmetry of the dipole as shown in the figure. The bead is slightly displaced along the ring tangentially with the initial speed very close to 0. Ignore the effect of gravity, assuming that electric force are much greater than gravitational force. Then the question is, the normal force exerted by the rod on the bead will be what? Here Q is the angle between and radius vector of a bead, considering the dipoles at origin. So here 4 options are given for it. So first we will discuss about the diagram given here. If we draw a diagram like this, it will be like this. This is an circular rod in which a small electric dipole of dipole moment P is placed at the center of the circle, and the direction of dipole moment is given like this. This is the direction of dipole moment. This is the axis which is in the plane of symmetry of the dipole, and a bead is present at this point, and here R is the radius vector. If this bead displaces some place, then the angle will be theta. Let this angle will be theta. So in this movement, the normal force exerted by the circular rod on this bead will be what? And in the question it is given that the bead is charged, let it is Q, and the dipole moment is P. Here is the positive and this end is the negative charge. So it is a dipole and this is a bead having charge Q. Now we know that for circular motion of anything there will be a force required towards the center, that is centripetal force for the movement of this bead in this circular motion, and this centripetal force will be given by the electric force between the charges. So here the force radial means force along the radius vector. So force radial will be what? 2 kp cos theta divided by r square. This radial force will be equal to the required centripetal force for the movement of the ball in this circular rod. So the centripetal force is mv square by r. You can write centripetal force. As this radial force is equal to centripetal force, so there is no extra force acting on this charge for the movement of this bead in the circular rod. So you can say that the circular rod needs not to exert any force on the bead to sustain the circular motion of the bead. So you can say that the force exerted by the rod on the bead will be 0. So you can say that force by the rod on the bead is equal to 0. So from the options, our answer will be option number 3rd, that is 0. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.